With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states two identical balls, each having a charge of 2 into 10 raised to the power minus 7 coulomb and a mass of 100 gram, are suspended from a common point by two insulating strings, each 50 centimeter long. So we have been given two balls and they have been suspended by the common point with some string 50 centimeter long. The balls are held at a separation of 5 centimeter apart and then released. We have to find the electric force on one of the charged ball. We have to find the component of the resultant force on it along and perpendicular to the string. And next we have to find the tension in the string, and in the last we have to find the acceleration of the ball. So let us try to draw a simple diagram for better understanding of this question. So you can see here I have drawn the diagram. So these are the two balls and they have, let us say, mass m, each equals to 100 gram, and they have charge q, each equals to 2 into 10 raised to the power minus 7 coulombs. Now since they are charged and they have same nature of charges, so they will repel each other with an electrostatic force F, which will be acting on this ball, which will be acting in this direction. Now this ball will have some weight which will simply act in this direction, and the resultant of these forces will simply cause tension in the string, and it will also cause the acceleration of the string. Now we also have to find the component of these forces along the string and perpendicular to the string. So let us draw a diagram, let us draw a line perpendicular to this string like this, and let us do the component of these forces along these lines. Now we can see here there will be one component of mg along this direction, which will be simply mg cos theta. And similarly, if this angle is theta, so this will be 90 minus theta, and this angle will be theta. So Fe will have a component along this. So Fe will have a component here, which is Fe cos theta. And along this line, this will be Fe sin theta. Right? So I can write that here. So it will be Fe sin theta. Similarly, mg will have a component along this line. You can see that this is mg, so mg will have a component along this. So I can add here, this will be mg cos theta, and mg will have a component perpendicular to the string, which will be simply mg sin theta. Now let us try to find all the parts one by one. Let us first try to find the first part, the electric force on one of the charged ball. So we need to simply apply Coulomb's law to find the electric force on one of the ball, which is simply equals to 1 upon 4 pi epsilon naught. Since the charge on both the balls are same, so this will be q square divided by, let us say the distance between them is simply x. We are taking this distance as x, so q square divided by x square. Let us now put the values here. So this is 9 into 10 raised to the power 9 into, this is 2 into 10 raised to the power minus 7 coulombs square divided by the distance between the balls is simply 5 centimeter, and we can write that as 0.05 square. So on solving this, what we get force as 0.144 Newton. Now let us try to do the next part. So in the next part, we have to find the component of resultant force on it along and perpendicular to the string. Very clearly we can see that along the string there is no motion. So the resultant of all the forces along the string will be simply equals to 0. So the resultant of all the forces along the string is simply 0. Now let us try to find the resultant forces perpendicular to the string. So if we find resultant forces perpendicular to the string, that will be simply the difference of these two forces mg sin theta minus Fe cos theta. Minus Fe cos theta. So if we put the values, let us try to put the value. The mass is simply 0.1 kilogram here. The value of g we can take as 10 into sin theta. We can find sin theta from here. So you can see we can find sin theta from here. Let us find sin theta separately here. So sin theta will be simply equals to perpendicular, which is 5 by 2 divided by hypotenuse. So if we solve from here, what we get theta is simply equals to 2.87 degrees. Now let us try to put the values here. Sine 2.87 minus Fe we have already found out 0.144 cos 2.87. So if we solve this, what we get resultant force perpendicular to the string to be simply, so this is the answer, we get perpendicular force along the string will be simply 0.94 Newton. Now let us try to solve for the third part. So in the third part, we need to find the tension in the string. So this force Fe sine theta plus mg cos theta will simply provide us the tension. So this force tension will be simply given by Fe sine theta plus mg cos theta. Now if we put the values and solve, what we get, this is 0.144 sine 2.87 plus mass is simply 0.1 and we are taking g as 10 cos 2.87. So if we solve for this, what we get tension equals, so this will be the tension. If we solve for this tension will be 1.005 Newton. Now let us try to solve the fourth and the final part. Now we know that the perpendicular component will simply provide the accelerations to the ball. So we can write r perpendicular along the string is simply equals to mass times the acceleration of the balls. So r perpendicular we have found out 0.94. This is simply 0.1 times a. So from here, if we solve, this will be 0.94 divided by 0.1. So this will be 9.4 meter per second square. So this is the answer to the final part. Now I hope you understood the explanation for all the parts. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.